everyone. This is Jeyapradha, Assistant Professor, Department of Computer Applications. Today I am going to talk about types and applications of queue. Before go to the topic, let's see the learning objectives. So first one, we have able to understand the fundamental concepts and operations of queue. Then we have to differentiate various types of queues and their implementations. Finally, we have analyzed the performance implications of different queues. So first one, what is queue? A queue is a basic concept in computer science used for storing and managing data in a specific order, because it follows the principles of FIFO, means first in, first out. In this queue, the first element added to the queue is the first one to be removed. So the queues are commonly used in various algorithms and applications for their simplicity and efficiency for managing data flow. For example, in cinema hall ticket queue, the person who enters first gets the first ticket, and the person who enters last gets the ticket last. So it operates like a line where elements are added at one end, that is called rear, and removed from the other end, that is called front. The diagram shows the FIFO representation of queue. Let's see about the basic operations of queue. First one, NQ. NQ, or we have said this insert. Add an element to the end of the queue. The second operation is DQ, that means delete. So it removes the element from the front of the queue. Third one is peek. It returns the element at the front of the queue without removing it. Fourth one is empty, because it checks if the queue is full or empty. So final one is full. It checks the queue is full or not. Let's move towards the types of queue. There are four different types of queues, that are simple queue or linear queue, circular queue, priority queue, double-ended queue or DQ. Let's see one by one in detail. So first type is linear queue. A simple queue is a linear data structure that follows the FIFO principle. It allows elements to be added to the end of the queue rear and removed from the front. The two main operations performed on a simple queue are NQ and DQ. That means the element can be added to the rear and it removed from the front. A simple queue can be implemented by using an array or a linked list. It is used in many applications like managing tasks in an OS, implementing communication protocols in networks, or stimulating some real life scenarios. Here we saw the working of linear queue. We have two pointers, front and rear. So front track the first element of the queue, rear track the last element of the queue. So initially both values have set to -1. So during NQ operation, first checks if the queue is full. Then for the first element, set the value of front to 0 and then increase the rear value index by 1. So add the new element in the position pointed by the rear. During DQ operation, checks if the queue is empty. If it is not empty, then return the value pointed by front. Also the front index value can be increased by 1. For the last element, again we have to reset the values of both front and rear to -1. So the next one is circular queue, in which the last element points to the first element and making a circular link. A circular queue uses a circular buffer to store elements. Comparing to linear queue which has a fixed size, but a circular queue uses a circular buffer that can be dynamically resized. In a circular queue, the front and rear points wrap around the buffer. So after reaching the end, it allows to reuse the space that can be freed up by the DQ operations. Circular queue is useful in many applications for managing a limited amount of memory in real-time systems. It also solves the problem of overflow that have commonly occurred in linear queue. Here we saw the working of circular queue, which performs the same operations like NQ and DQ as we saw earlier in the slide, but with two additional cases. Case 1, we have to check front equal to 0 and rear equal to size -1. So second case, we have to check front equal to rear plus 1, because the second case happens when rear starts from 0 due to circular increment, and when its value is reached just to 1, then the queue is considered as a full. So, third type is a priority queue. In priority queue, each element is assigned a priority and the elements are served in the order of priority, which means the highest priority element is served first and the lowest priority element is served last. The priority of each element can be determined based on different criteria like arrival time, size or value, etc. So, in the priority queue, the insertion is done based on the arrival time, whereas the deletion is done based on the priority assigned. So, the priority queue can be implemented using array, linked list, heap and binary tree. It is used in many real world applications like scheduling process in OS, implementing shortest path algorithms in graph theory or implementing event driven simulations like. So, next one, the last type is a DQ. DQ means double ended queue where elements can be inserted and removed from both the ends of the queue, whether the front or the rear or end of the queue. It is a hybrid between a stack and queue because it supports both LIFO, last in first out, and FIFO operations, first in first out operations. It is used in many applications like undo operations on many softwares, to store browser histories and for implementing both stacks and queues in a data structures. So, in addition to DQ, we have other two types of DQs. So, that is input restricted DQ and output restricted DQ. Input restricted DQ, as the name implies, it input restricted insertion operation can be performed at only one end, whereas deletion operation can be done from both the ends. Output restricted DQ, deletion operation can be performed at a single end, whereas the insertion operation can be performed at both the ends. So, let us see the applications of queues. So, queues plays a vital role in various aspects of our digital lives, from handling customer services, inquiries to optimize traffic flows. Queues silently streamline process and enable efficient resource management. So, let us discuss about the applications of queue that impact industries and systems we interact with daily. Let us take a look at one of the most basic applications of queue. Think a queue at the railway station ticket counter. The person standing first in the queue gets the ticket and leaves the group, while a new person joins at the back end of the queue. So, this is the working center of a queue. So, this follows the FIFO principle. So, applications of queue in data structure, it can be used to schedule jobs and ensure that they are executed in the correct order. It also can be used to manage the order in which print jobs are set to printer. It can be used to implement the breadth-first search algorithms. So, another applications of queue in network basis, the switches and routers play an important part in networks. So, we can use queues with them. There are various mail queues in networks. So, apart from data structures and networks, application queue can be applied in OS also. So, it is used for CPU scheduling and for spooling in printers. Also, queue can be used in memory management. So, some other applications of queues are handling website traffic by implementing virtual HTTP request queue, applied as buffers on playing music in the MP3 players or CD players. Traffic management, during traffic signals, use queues to manage interactions. So, real time applications of queues are luggage checking machine, vehicles on toll tax bridge, one way exit, patients waiting outside the doctor's clinic, phone answering system. So, these are the real time applications of queues. So, in summary, the diverse types of queues and their broad ranges of applications underscore their importance in effective data management and the process optimization. So, by choosing the appropriate queue types and understanding its application, help the developers to solve complex problems more efficiently and design robust systems. Thank you for watching, viewers.